Okay, so let's begin. In the previous video I have forgot to mention another substitution reaction, which is the substitution by RNH2 group, so which is also called the Hofmann ammonolysis. So let's see what's happening there. So I give the heading by, I forgot the number, maybe number 4 I think, substitution, under substitution reaction. So by RNH2 group, right? So let's see what's happening here. So you take anything Rx, I'm just giving the layout, you treat it with RNH2. Okay, now what's happening here? Okay, let's not take Rx, let's us take RNH2. It will be easier for us to understand, and you treat it with Rx. The thing is same, but in this way it will be easier for us to understand. What's happening here is it becomes R in H and R, and as a byproduct, see one H is coming out from here, so you get HX. Now if more amount of NH2 is present here, or Rx is present, I'm sorry, if more amount of Rx is present, this hydrogen also get removed, and as a result we get R in R, and here also R, and as an outcome of this you get HX. Okay, now if more amount of alkyl halide is present, okay, Rx, now what will happen here is some sort of this will form, a salt will form, complex or salt will form. Okay, this will have a plus charge obviously, and this X, since there is no hydrogen, so it will get bonded with this. So a salt of this will form, and this salt has a special name which is called the quaternary ammonium salt, right? And this entire process which I have shown you here is called Hofmann ammonolysis. Right? This entire thing is called Hofmann ammonolysis. Okay, so this was the end of substitution reaction at last. I forgot to mention it, this one in the last video. Now we will come to the main portion of this lecture, or the main part, which is the elimination reaction of haloalkane and haloarenes. I'm sorry, haloalkane only. So let's clear out the board. Okay, so it will be elimination reaction this time. Right, let's give the heading elimination reaction. Let's us find out what's happening in elimination reaction. So give the heading elimination. Okay, so elimination reaction of haloalkane. In this case, let us take any haloalkane. Let us directly go to the example, CH3 CHBr, and here again CH3. You treat it with a weak nucleophile. Let us take CH3OH, which is a weak nucleophile, right? Okay, and we get the temperature at around 60 degrees centigrade. Okay, elimination occurs at a high temperature. So as a result, this bromine will get eliminated, and now the question is, bond can form this side also, but since this is symmetric from either end, so it will be not an issue in this case. Okay, so we get CH3 CH2 double CH2, not CH2, double bonded CH2. Why? Because this bond is just opening and this is getting bonded here, and bromine is coming out. So this is the product now. Okay, so when you perform elimination reaction with your alkyl halide with a weak nucleophile like CH3OH at 60 degrees centigrade, you get some sort of alkene like propane in this case. But this was the case when we have the alkyl halide which is symmetric from either end. But if you take unsymmetric alkyl halide, okay, now here another thing can happen. Okay, if the temperature is at low, let us assume the temperature is at 20 degrees centigrade, then a thing is happening. See, we get CH3 and the reagent is same. Okay, CH3OH. We get a thing which is CH3, CH, and this is OCH3, and we get CH3. This H is getting attached over here. So temperature factor is very important in this case. We have to keep in mind, if 60 degree, then propene or alkene, any sort of that, and if 20 degrees centigrade or lower temperature, you get this one. Okay, now this was the case. Now the thing I was saying, I will come to that portion. Now this was the case where the alkene was, or the alkyl halide was symmetric from both the ends. But if we consider the case of this thing, suppose we take CH3, CH2, here you take CH, Br, and here you take CH3. See, this is not symmetric from either end. One from this end and this end, the compound looks different, right? So when you treat it with your, let us consider CH3OH, okay, and you maintain a very high temperature at around take 80 degrees centigrade. Okay, now what you get here is this bond will open, right? Now this bond can form this side also and this side also, right? So we can get two things, CH3, CH, double bonded CH, and here is CH3. Let us see if all the bonds of carbon is matched, which is this one will be 1, 2, 3, 4, 1, 2, 3, and here 4. Yes, you can get this also, and if this bond is attached or getting replaced over here, we get CH3, CH, this will be CH2 only, and this will be CH double bonded CH2, right everyone? Now the question comes, which thing is the major product and which one is the minor product? So this one is the major product. Now why this is the major product, I am saying that, and this is the minor product. Okay, obviously. Now why this is the major product, I call this, because you have to count the number of alpha hydrogen. Okay, see, if you consider here, you have 6 alpha hydrogen. See, alpha hydrogen, 6 alpha hydrogen, and in this case if you see here, you have only 2 alpha hydrogen. See, so it is less stable naturally because the number of alpha hydrogen is less, and this is more stable. So the product which is more stable will be preferred. Okay, so this is the major product. Now if you observe this, 2 types of product can be formed from here, right? A cis form can be formed from here, and a trans form can also be formed. Now this form cannot form any cis form, so this thing will end over here. Now from here you get probability for the formation of your cis form also, and you can also form the trans form also, right? Now among this cis and trans, which is more stable? We know trans is more stable, right? So trans will be a major factor, major product. Okay, and here cis will be minor product. Okay, now these minor products are also called the Hofmann products. So this is also called Hofmann product, right everyone? Okay, and the stability factor which we consider this as major and this is minor, that is called Satyzef rule. Okay, SATYZEFS, Satyzef rule, right, where we did this by counting the alpha hydrogen. That rule is called the Satyzef rule, right. Now moving ahead, the next thing we come to the reactions of metal, reaction of haloalkane with metal. So let's clear out. Okay, so let's find out the reactions of haloalkane with metals. So I am writing here metals, metallic. So metallic reactions of haloalkane. Okay, so under metallic reactions, let's first come with the reactions of with sodium. Okay, I'm sorry. So reactions with sodium. Now, if you see the reaction with sodium, let us take an alkyl halide Rx plus Na. Okay. Now in this reaction, we not only one mole of alkyl halide will be present. There can be many alkyl halide, right? So let us take another one. So Xr, I am writing it in this way, so it will be easier for us to understand. Okay. So what we get here is called, so bond will be cleaved in this way. Okay. Okay. So what we get here is R, which is called the alkane, and what you get here is you have to take 2 moles of Na, and so you get 2NaX. Okay. Now you should be familiar with this reaction in class 11 about the preparation of alkane. Okay, and this reaction also has a name which is called the Ward's reaction, WURTZ, Ward's reaction. Right. So reaction of alkyl halide with sodium, with 2 moles of sodium, you get alkane and 2 moles of NaX, X the halogen, and the reaction which we do is called the Ward's reaction. Okay, the name of the reaction is called Ward's reaction. Okay. Next, if we do the same thing with zinc, okay, let's do here. When you do it with zinc, we take Rx, we do the same thing, just in case of Na, you take zinc plus 2 moles of Zn plus Xr. Okay, now see, the same thing is happening here, and you get Rr plus 2 Zn X. Okay, sorry, this will be only Zn because Zn has a valency of 2. This will be Znx. So this reaction is also called Frankland reaction, Frankland, Frankland reaction. So this is Frankland reaction. Okay. Now under the category we have the next one, which is reaction with magnesium. Okay. So let's change this to magnesium. So this will be number 3, which is reaction with magnesium. Okay. So in reaction of magnesium, the same thing is happening. If you take Rx and you treat it with Mg. Okay. So what is happening here is we get R Mg X, or you can write it as this R Mg X. Now this is a very popular compound in organic chemistry. This is called Grignard reagent. Okay, this is called Grignard reagent. This RMGX, this is a very important compound. From this compound you can prepare anything in organic chemistry. Literally anything can be prepared. Aldehydes, ketones, carboxylic acids, even amines can also be prepared from this Grignard reagent. So with magnesium we can write it as formation of Grignard's reagent, right? So this thing is being formed, right? So this was about the preparation of Grignard reagent, and this was all about the preparation of, or preparation not, this was all about the reactions of your alkyl halides with metals. So in the next class, or the next video rather, we will see about the preparation of your haloarenes. Followed by that we will learn about the preparation of aryl halides, or the reactions of aryl halides rather. So in next two videos the chapter will be over. So thanks for watching. All the very best.